Congrats on making it through your first day of school. We're now going to start the countdown to summer of 2015. There are 177 days left of school. Isn't that a depressing thought? Actually, I'm excited about this school year. My name is Mrs. Irwin. I'm one of the Algebra 2 teachers, and I will be doing the videos for the first couple weeks of school. As you were explained in your class today, we're going to be doing a flipped classroom, which means we're going to do the teaching, quote unquote, at night, and you're going to be doing all the practice during the day in your classroom. So you're going to be learning how to take notes, and we expect to see everything that is in the video in your notes, and we will be checking and grading your notes. The first video is on expressions and equations and literal equations, but first we need to differentiate between an expression and an equation. An equation has an equal sign. Pretty easy. An equation with an equal sign can be solved. These over here on the left are expressions. They don't have equal signs, therefore they can't be solved. They can be simplified. What I'd like you to do right now is pause your computer and copy down everything that is on this page right now. So we're going to start on the left with the expressions. And expressions, since they can be simplified, we have to combine like terms. And the first question that pops up is, what the heck is a term? Terms will be separated by addition and subtraction. So in this first example, there's a subtraction and an addition, which means I have one term, two terms, three terms. In the next example, I have 1, 2, 3, 4, 5 terms. And in this last example, there are no addition or subtraction breaking this up, so this would just be one term. So when we combine like terms, we're looking for variables in the terms. They must match exactly. And in this first term, this x has an exponent of 1 and this x has an exponent of 1. Therefore, these are like terms and I can combine them. So if I combine negative 5x's with positive 7x's, I'm going to get a positive 2x. This negative 4, there's no other number in this expression, so it just tags on at the end, and that's all I can do to this, is simplify it by combining like terms. In the next example, you can see I have an x squared and a negative 2x squared. These variables are exactly the same, so these two terms can be combined into negative 1x squared. I don't really need this 1 in front, because if there's no number in front, it's assumed that it's a 1. I then go to the next smallest exponent in my variables. That has an x to the first. There's no other x to the first, so negative 7x goes next. My numbers, 3 and 15, positive 3, positive 15 will give me a positive 18. And last but not least, we have this term here, but since it's only one term, there's no other term to combine it to, so it will stay negative 2g squared h cubed j. So on the right, like I said, because we have an equal sign, we have an equation, and we're going to be solving equations in the next couple days. So the first thing I want you to do is I want you to draw a line down the equal sign, and I want you to circle the variable that you're solving for. Since there's only one x, I'm obviously solving for the x. Then we're going to look, and we're going to see there are two terms here. There's a 2 times x, and there's a plus 7. And I need to get this x guy all by himself over here. So the first step I'm going to do is I'm going to subtract a 7 here. If I subtract 7 from this side, this will become 0. But whatever I do on the left side of the line, I also must do on the right side of the line. So I'm going to also subtract 7. Since I didn't do anything to the first term, it's going to come down and become 2x. Like I said, this cancels out to become 0. the equal sign will stay on the line. Negative 15 plus negative 7. Negative 15 subtract 7. Think of a negative as owing money. If I owe $15 and I owe $7 more, I owe $22. Now, again, I'm going to circle that variable because I'm still trying to get that x all by itself, and I know that 2 and x are connected here by multiplication. So I'm going to do one of two things. I can either do the opposite, which would be divide by 2, because 2 over 2 would give me 1, or I can also multiply by the reciprocal. So I'm going to multiply. The reciprocal is just flipping the number over, 1 over 2. This is a better habit to get into, and you'll see why in the next page when we have a more complicated equation. 1/2 times 2. So remember, this is a 2 up here. Okay, and I'm multiplying by 2 over 1. And when I multiply across the top. So 2 over 1. 1 times 2 is going to give me 2. Then I'm going to multiply across the bottom. 2 times 1 is going to give me 2. And then I have my x. But 2 over 2, x is 1. Over here, I'm going to do the same thing. Negative 22 times 1 is going to give me negative 22, and 1 times 2 is going to give me 2. So 2 over 2 becomes 1x, and negative 22 over 2 becomes negative 11, and this would be my answer. We're going to talk in class about the couple different ways to check your answers quickly. So here's a little more complicated problem, and I'm going to draw the white line down the equal sign, but I'm going to run out of room on the right, so I'm just going to sway it this way a little bit. Okay, I'm also going to circle a variable. I'm going to circle this one for now. You can see that I have 2 on this side. I have an x here and I have an x here. You'll see how we take care of that in a minute. The second thing I'm going to do is I'm going to remember PEMDAS. PEMDAS is our order of operations, so the first thing I have to do is take care of the parentheses. This 1/2 is only going to distribute into this set of parentheses. The negative 2/5 will distribute into this parentheses. So 1/2 times x gives me 1/2 x. And let's review how to multiply fractions and non-fractions. So 1/2 times 3. 3 is over 1. And I'm going to multiply across the top, 3 times 1, and across the bottom, 2 times 1. And I'm going to get 3 over 2. So when I multiply here, I have negative 2 over 5 times 3. I'm going to put it over 1. Across the top gives me negative 6. Across the bottom gives me 5. So I have negative 6 over 5x. A negative times a negative is a positive. Multiply across the top and across the bottom equals 9. The next thing I'm going to do is combine like terms just like before. This and this term would be alike, and the 3/2 and the 14/5. Now, if we were going to add these by hand, we would find a common denominator. We'll talk about common denominators later, but for now, we're just going to use our calculator and add these. And if you add 1/2 plus a negative 6/5, you're going to get negative 7/10 x. 3/2 plus 14/5 gives me plus 43 over 10. And I'm going to have equals 9. Now, I'm going to move that down a little bit. Negative 7 over 10x plus 43 over 10 equals 9. And now I'm going to do step number 4. I'm going to move my variables to the left. Well, the only variable I have is right here. It's what I'm solving for. It's already on the left, so I don't need to do this step. The next step I'm going to do is I'm going to move my numbers to the right. So I'm going to subtract the 43 over 10 from both sides. Draw my line. Negative 7 over 10x I didn't touch. This will become 0. 9 minus 43 over 10 is going to be 47 over 10. And here is why I like multiplying by the reciprocal. So again, I'm going to flip it, and it has to be the same sign because a negative times a negative will give me the positive. If I multiply across the top here, negative 10 times negative 7 is negative 70 over, or positive 70 over positive 70 will give me 1. That's my goal. I need to have 1x. But if I'm going to multiply by the reciprocal there, I need to multiply by the reciprocal here, and this will give me negative 470 over 10, nope, over 70, which will give me x equals negative 47 over 7. Again, we will learn to check these answers in class. And last thing we want to do is just say that our last step was to either multiply by the reciprocal or divide, but dividing by a fraction like this would have made that very complicated. So we multiplied by the reciprocal. So at this point, I'd like you to copy down this problem and pause your computer. I'd like you to work through the problem doing the same exact steps, and when you get to the end, then press play and see if you're right. We will again learn how to check on our calculator when we get back to class. So just a couple things I want to point out on this. Right here, don't forget that a negative times a negative is a positive 15, okay? And this negative 3 is only distributed inside the parentheses, so it does not distribute to the 7. Also down here, don't forget that a negative divided by a negative is a positive. I don't have to write the positive, so I can not put the positive there. But the other thing I want to point out is 25 divided by 7 is not perfect, so it's not 6, it's not 7, so I'm just going to leave it as 25 divided by 7. I'm not going to change it to a decimal at this point. So up until now, you've been solving equations with only one variable, an x. It could be an a, it could be a p, it doesn't matter, but if there's only one variable, then it makes it very obvious what I'm solving for. In these two equations that you see on this page, you can see there are multiple variables. So before anything starts, the instructions must tell you which variable to solve for. When you look at the first one, 3x minus 5y equals 10, I think most of you will say, well, I'm solving for y, which the majority of the times that's going to be the case. But remember, the instructions tell you which variable to solve for. I could ask you to solve for x, but in this case, I am going to ask you to solve for y. The same first step that we've been doing, we're going to circle what we are solving for, and we're going to draw a line down the equal sign. So we're going to circle the y, and we're going to draw a line down the equal sign. Okay, now remember, this is a married couple. Okay, they are together, so I must first get rid of the 3x. My job is to get the y on this side completely by itself. So I'm going to first get rid of the 3x, and since there's a hidden positive here, I'm going to subtract the 3x from both sides. And we've talked about this before. 3x minus 3x is 0. Don't forget the negative 5y comes down. Now, 10 minus 3x, I can't do 10 minus 3 is 7x because these are not like terms. Remember, in order to be like terms, they have to have the same exact variable factors. So 10 minus 3x, we're actually cannot combine anything, so we're going to write this as negative 3x, and that 10 is plus. Okay? And you know that this is a negative 5 times y, So we're now going to divide by the negative 5 because the negative 5 over negative 5 is 1. But if I do that, I have to divide this side by negative 5. It makes it tricky when there are two terms because the negative 5 is actually dividing this term and this term. So I'm going to end up with y. I have a negative 3 over negative 5, so that's going to be positive 3 over 5x, and a positive 10 divided by negative 5, which will be minus 2. And this will be my answer. In the next equation, let's just pick a letter to solve for. Let's solve for m. So solve for m. Okay. So again, first step is circle and put a line down the equal sign. We're going to solve for m, put a line down the equal sign. So let's make sure we write the steps this time. These two are stuck together by multiplication, so the first step I have to do is I have to add or subtract any terms. So I'm going to subtract this b over to this side. Notice I never put these directly underneath each other. I always kind of put it off to the side, like 10 minus 3x, y minus b. I do this because these are not like terms. It's just an added reminder. Y minus b, they aren't like terms, so it stays y minus b, and over here I have mx. Again, I'm solving for m. The m and the x are factors connected by multiplication, so I'm going to divide both, divide both sides by x, because x over x will become 1. Divide this side over x. But please remember that the x actually divides both of these terms. So my final answer is going to be y over x minus b over x equals m.